Cody, what's up, man? Thanks so much for deciding to join and chat about everything 3D printing, specifically printing tissue. So, why don't you give people a kind of a background as to who you are, what you do, and let's jump into what that even means.
Sure. So I grew up in the Bay Area. I was perhaps one of the few who was not in tech who just happened to grow up in the area. Then I went to a small arts college for undergrad, Harvey College, where I was one of 800 students. So super, super tiny environment. I just studied general engineering there because frankly, I really had no idea what I wanted to pursue. I'm like, I might as well do engineering. It's pretty flexible moving forward. And then I started doing research in Australia. Had the opportunity through an NSF grant to study at the University of New South Wales over in Sydney. And I had never considered doing a PhD. No one in my family had done one. Didn't have any professors or any, high level researchers. And so my professor pulled me aside my junior year, and she's like, "Hey, you should, you're pretty good at research. You should consider doing a PhD." I was like, "Oh, okay, well, maybe."
Sounds
I
good.
think,
I'm going to commit six
yeah,
to 8 years of my life to get this.
exactly. But I knew I did know I liked research. That was evident to me kind of halfway through the experience. And I had always liked biology, kind of always had a passion for it. Had somewhat been maybe bullied out of it to an extent in undergrad, because they always said, if you study biology, you have to go to grad school or you have to go to med school, right? And at that point, I'm like,
Mhm.
well, I don't want to lock in that way. I want to get more of a quantitative background. In hindsight, maybe I should have just majored in biology, but I'm grateful for it brought me so far. And so I applied to programs that were at the, I would say, intersection of biology and engineering. So in some programs, that was like biological engineering, biomolecular engineering, biomedical engineering. Thankfully, UT Austin decided to take me in. And I really liked the environment, really liked the people and professors there. So I moved to Texas, and I've been here since. I've been here 10 years now.
Awesome.
And it was really a great program. I learned a lot. Finished up in 2020, right in the middle of the pandemic. So I gave my defense virtually, didn't really get to walk. So it's kind of a bummer.
Oh man.
Uh, but at that point, I was we weren't engaged yet, but I was almost engaged to my fiance at the time. And so I was looking to stay in the Central Texas area. I was TAing for a different professor. He pulled me aside. He's like, "Hey, the small arts college in the area, like they have a job opening. You should check them out." I was like, "Oh, okay." Well, I wasn't really thinking about postdocing. A couple more years at very low pay, just to end up in a really high pressure job.
Sure.
And so I was like, I enjoy teaching with the students. I enjoy interacting with them. So this could be a really good fit, bring me back to my undergraduate roots. And it turned out to be a fantastic fit on the whole. So I'm up in Georgetown now at Southwestern University. We're about a 1,600 person liberal arts college. We don't have an engineering program. So I'm a professor of physics. I always have to say I'm not a physicist, don't have extensive training in the physics realm, but most of our physics majors do go on to engineering careers, engineering
Hmm.
graduate school. And so they wanted to hire someone who had that engineering experience. And here we are.
Awesome. Very cool. So, what kind of research are you specializing in now then? Or what did you especially do before as well?
Yeah, I can start with before because it might make the story make more sense.
Hmm.
So
Hmm.
in undergrad, I researched metals known as high entropy alloys. Basically, you can mix a bunch of different metals together, like four or five of them, and they create some really interesting properties. And I discovered I liked the materials aspect, but I still wanted to include the biology in some way. And so when I was looking at PhD programs, I was looking very specifically for biomaterials, and that's what I ended up doing.
Hmm.
So for my graduate work, I used polymer. I used hydrogel materials. It's like what a contact lens is made out of is a hydrogel. They're polymers that can swell and take on a lot of water.
Hmm.
And I put cells into these. So these were cells derived from iPSCs or induced pluripotent stem cells. For these
Yes.
cells, yeah,
These are
go
the
for it.
ones that can turn into a lot of different things, right? It-
Exactly. So you can
yeah.
take a skin cell and reprogram it back to an embryonic-like state, which is really cool. Won the Nobel Prize about a decade and a half ago, and it's really nice from an ethical standpoint. As a practicing Catholic, it was nice for me to know that I could work with these cells without any kind of ethical considerations because they are adult somatic cells. No embryo tissue was generated or destroyed in the creation of these stem cells, and so for me, it was kind of a perfect opportunity.
Yeah, that's super cool. These are the types of cells that if they go haywire in different parts of your body, can they turn into other organs or other
Exactly. So,
tissues, right? So this is like someone has an ear growing out of their back. You're like, that was the cell that went sideways somewhere in the at the beginning, right? Isn't that kind of what it is?
Yeah. So the form what's known as a teratoma. And so that's
Mhm.
like these lumps of tissue that basically will contain a lot of different cell types. And that's actually a way that you can test that you've generated these cells correctly. is you can take the generated cells, inject them into a rat or similar organism, and see if you get teratoma formation, because that tells
Yeah.
you, yeah, these cells are pluripotent. But say you go abroad to maybe a shady stem cell clinic and they inject you with God knows what, then that could easily be a side effect if that's not being regulated properly.
You got a bum knee and you go somewhere and then they
Oh
inject
yeah.
you with something crazy and then all of a sudden you get teeth. It always comes back to teeth for me. You know, it's interesting because in dental school and med school, I'm sure it's the same. They always show you the craziest, gnarliest photos you can possibly imagine. And it's like the person who has, when they're talking about these types of teeth, who has teeth growing, you know, behind their neck or something. I'm being a little facetious, but really, I mean, it's a really amazing. It's really amazing to think of these types of cells can do such amazing. You know, you can basically transform them into what you're looking to transform them into. Isn't that right?
Yep.
So,
So you can control like their physical and chemical environment to drive them basically wherever you want.
and is this where it comes into printing tissue
Yeah.
growing tissue? So how does that connect to it then?
So I was specifically focused on growing vascular networks or kind of these small capillaries within these hydrogels. And what I was doing, I would say, was fairly primitive. I was using well established materials. Our total tissue size was about 50 microliters, which is really, really, really tiny, you know, smaller than the area of my pinky nail. And so, as I was thinking through this, one of the major barriers to generating tissue is a functional vascular network. So you
Mm-hmm.
can create this big old heart, this big old liver, et cetera. But if you can't build some sort of network that can then perfuse it and make sure there's delivery of oxygen and nutrients to every, you know, one of the billions of cells that's entrapped within that organ that you've generated, then it's effectively useless. And so that's considered one of the holy grails of the field of tissue engineering and regenerative medicine is, hey, you know, can you actually generate a functional vascular network that can anastomose to the existing
Mm-hmm.
network in the human body, or at least at a bare minimum, be perfused by some sort of device in the laboratory.
So that is super interesting. Hadn't thought about it, but it totally makes sense. I mean, because when you say anastomose, that basically means the growth of
The growth
these
and
super
connection.
highways, right?
Mhm.
Connect, you right, connection. And I remember what you know studying the basic sciences and trying to visual. I'm a very visual learner, so trying to visualize those oxygens and the oxygen, the nutrients, and the different things that the cells need to live and the body ultimately needs to live, moving towards that direction. So for you, you're trying to people are trying to crack the code on how to get that delivery system made at scale. Is that right? And then not
Exactly.
only at scale, but then have it grow on its own. So there is a tremendous amount of orchestrating that needs to be done. And so that's what leads me to when people are growing meat in labs, they have to do a similar thing, correct?
Yeah. So my advisor actually started her own company that was called BioBQ, which is focused on growing, you know, barbecue grade meat.
So
So
how successful has this been? Not only for food, but also for I mean useful. Like what are the use cases and yeah.
So I think with regards to food, it faces a bit of an uphill battle. And that's in the sense of for now to grow enough cells for this to be viable, it's extremely expensive in terms of media costs. You know, I would personally just trying to keep my cells alive and I was culturing millions of cells, which in the scale of things is very, very few cells. Maybe a couple six wells that are about the size, a little larger than couple quarters put together. And even that, me culturing that consistently throughout a month would run through thousands of dollars worth of media. So the scale to the point where you have enough cells where you can create, say, even, you know, a 6 ounce steak, just the cost and the amount of resources you'd have to use to create that are enormous. And part of what makes food so palatable to us is its structure. You know, the fact that you can taste like the fibers in the meat, that you have those sear marks. It's not just a lump of ground meat, you know, hence part of why ground meat's cheaper because it's cheaper to produce, but also because it's not as appetizing to us on the
Hmm.
whole. So, yeah.
The first iteration is basically going to be mashed potato like spam that gets you know spit out of a toothpaste. That's how I'm kind of envisioning it. I know that there is a lot of hype around lab grown meat recently, the past few years, and people go, this is it. We're never going to have cows again. We're going to have this lab grown meat and it's going to taste delicious. Sounds like that's not necessarily true.
I think it could be true in the future. I'm not an expert in this field, but I think I am close enough to realize it's not going to be something in our immediate future. Or if it
Hmm.
is, it would be something you go to a five-star restaurant and you pay, you know, $400 for this very small steak. Like I think we'll see it come into the market, but not not at any sort of appreciable scale. Not to mention, we're already seeing, I think, some struggles with the adoption of plant-based meats. I
Mm,
remember, when I was graduating in high school, this was being sold as the next revolution. Everyone will just, eat these meats that are generated from all these various vegetables on the whole. And I've seen it in the grocery stores. It's a thing, but they remain surprisingly expensive for what they are. And at least growth wise, I personally haven't seen much. I mean, that could be contradicted by the growth of these companies, but I know one or two in particular that have really just struggled on the whole. And I don't really know why. It could be people are really attached to that taste and texture. And if they are, then frankly, that's going to be also a challenge with engineered meat because it takes a lot of work to exactly match that.
absolutely. I no disrespect to vegans out there, but
It's
I
a
think
challenge.
it's a huge challenge. And the thing that always gets me is folks are looking for less process. And they go, oh, I'm gonna go non-meat, non-dairy, non-everything, and I'm gonna try to be as natural as possible. But then you taste something that's supposed to be look like meat, taste like meat, sound like meat, but it's made out of beans. And I go, this is so processed. It's so incredibly processed. So how close are people? I recently I saw that there's a company that was a publicly traded company, and their stock went way up because they got a deal with the government for tissue grafts for the Ukraine war. So sending out tissue grafts out there. I would imagine that if we're able to create human tissues, even as simple as a tissue graft, because a tissue graft for folks who don't know, really small piece of tissue, talking about 5 millimeters by 5 millimeters, or even say a bone graft, way less complex than an entire organ, for instance. But is it getting close to where we can have lab grown tissue grafts like that?
I think we're making some progress. I think we're especially seeing some progress when it comes to these larger blood vessels. So there's at least one company I know of out there that's growing these pretty large arteries, that can be used instead of having to harvest an artery or vein somewhere else on your body to transplant it, or even possibly from a corpse, you can at least generate these in the lab and hopefully with a combination of immune suppressing drugs, hope you don't engender a reaction upon transplant, because that
Hmm.
really is, I think, one of the critical issues that faces this field is, I often compare engineering in the body to being even more difficult than engineering in space. Because in space, even though it's extremely difficult, you're facing a vacuum, but you're facing a vacuum in really low temperatures. Versus in the human body, you have literally an active defense system with your immune
Hmm.
system. There's a number of bad outcomes. You could have it actively attack the tissue. You could have it seal off the tissue. Um, Produce something known as a fibrous capsule. That's not necessarily as damaging immediately. You may think, oh, it's kind of nice, it's non interactive. But the problem is, a lot of these tissues you implant, you need them to be interactive. You need them to
Hmm.
graft, as you were just saying, and actually integrate with the host tissue. So I think we're making more progress on that. My hope is where we see the most progress is with cartilage. And I think
Hmm.
we'll see the most progress with cartilage precisely because it's a fairly basic tissue as far as tissues go. Has very few blood vessels, is
Yes,
almost
yes.
totally aneural. It's basically just a hunk of extracellular matrix. And right now, we don't have a lot of good synthetic substitutes. If you're unfortunate enough to tear your meniscus, while climbing or running or something similar, they're probably just going to shave off the damaged portion, and that's it, right? And if you have arthritis and you just have the degeneration of this cartilage, especially at your synovial joints, there's really no way to regenerate it, at least with current technology. You can prescribe medications to reduce that inflammation. You can do various things to alleviate the pain and discomfort, but everyone who's had arthritis is going to continue to have arthritis. Versus if we can maybe, especially with our recent technology, if we can, for example, get an MRI of that joint and then we can generate a piece of cartilage that's exactly the fit for your given kneecap, implant it. I mean, to me, I think that has some promise because that is a tissue that, in my mind at least, is not so horribly complicated that we have no hope of kind of replicating it in its entirety.
Absolutely. So, I mean, there's almost I wouldn't say infinite, but it seems like a multitude of variables that you're dealing with when you're trying to make this tissue. So you have to make it
Hmm.
so that it can get enough nutrients. But then you need to put it into the body that has its own defenses as trying to say, what the heck is this? This is a foreign body.
Yeah.
But then you need to make sure that the body itself doesn't start mutating because of this invasion. There's just a lot of programs, like biological programs, that have to be totally aligned, and then you have to predict how to react once it happens. And I guess This is when they talk about the oh my gosh, I'm blanking on the name. The medications that are given to suppress the immune system in order to allow the graft to grow and survive, then brings down the immune system for everything else that's trying to kill somebody, right?
Mhm.
With the viruses and bacteria that just live in our bodies naturally. That's quite a challenge. That's
It's a
quite
significant one.
that's
Yeah.
quite a challenge. So talking about kind of cartilage here, one of the things that we've been people have been hearing online with runners and things is, oh, if you have knee issues or you tear something, go get some stem cells. You know, just like we were joking about getting stem cells injected. What are people talking about when they say that, and how effective is it really? And what's happening there?
That's a good question. I think a lot of the mechanisms aren't particularly well studied since most of these are not FDA approved treatments. And, you, for example, hear about, Christian McCaffrey going over to Germany for the stem cell injections for, I think it was his Achilles. I don't remember the exact tendon that was injured. And he came back and seems to have recovered. So maybe there's something there. There's been a lot of cell based therapies throughout the years that have kind of gained some traction, shown some positive effects, but largely it seems overwhelmingly, at least from what I've seen, as most of these cells die almost immediately upon transfer. Uh,
Mm,
but the idea is, I think there's a couple different hypotheses. One is can be when the cells die, they do release a lot of antigens that activate the immune system in that area, which could maybe actually increase the wound healing response in that region.
mm,
Because previously, for whatever reason, it wasn't being activated. In that area of the injury. Another response is it's simply just a delivery of the cellular contents. So,
hmm.
if you're low in collagen in that area, and these cells you're injecting in this material have a bunch of collagen, well, it's just the breakdown of the cells that's actually giving you the raw materials to repair in that region. I've seen a lot of different reasons why some of these may show limited efficacy, but on the whole, I wouldn't say there's great science behind it at the moment, and that's part of what my whole field is built around is can we create better delivery vehicles? Can we create better scaffolds that contain these cells? But there's more and more evidence showing that maybe we just need to engineer really good scaffolds, and then the cells already in the human body will take care of the rest for us. And to
Hmm.
me, I think that's the more promising approach.
I'm kind of laughing here for people who can't see me because I'm thinking of a $50,000 price tag to acupuncture, because basically sounds like what it is, right? If you're just injecting, you're creating some inflammation, you're getting making the body helping the body get those nutrients to a specific area. Sounds like kind of why acupuncture can help out sometimes.
I believe it,
Um,
and the placebo effect is very real. If people are receiving kind of a real, it's amazing to me how little we still understand about the placebo effect, but that could really be playing a role as well. People genuinely think it's speeding up their healing. They might see a, a genuine response.
because there's statistical significance with the placebo effect, right?
Yeah, which is insane in itself. If you get 10-15% improvement with quite literally nothing, say a saline shot, for example, I mean, that's pretty cost effective.
Hmm.
That's a pretty incredible therapy, but we don't really understand the biomolecular mechanisms for what leads to that.
Absolutely, absolutely. So when people are saying 3D printing tissue, what they're really saying is that you're trying to induce certain cells to multiply in the way that you want. Is that basically it?
So we're using what I would say are materials that are meant to mimic the extracellular matrix. And maybe for our
Hmm.
audience members who aren't as maybe familiar with this type of biology, all of our cells kind of have a dense network of structural proteins that surround them and interact with them. So they exist to give mechanical support. The reason we don't just stand up and instantly collapse in the process is we've deposited a lot of extracellular matrix in these various tissues that provides kind of rigidity. But then on top of that, there's been more and more evidence that the extracellular matrix is a rich kind of chemical signaling area. And so it gives instructions to these cells for how should I divide, how should I migrate, should I differentiate to this other cell type. And so that's what I spent most of my graduate work doing was kind of working with these different materials. In my case, they were derived from collagen and hyaluronic acid, two that our audience probably are familiar with because they're found in many supplements and cosmetics, in any grocery store you go into. And idea is can we kind of engineer these materials to mimic as many aspects as we can? And
Mm,
obviously, what I was working with is a really, really limited model. But the idea is that you can turn these relatively simple materials into a bioink. So instead of, for a traditional 3D printing, maybe for audience members also who are not familiar with how that works, it's basically melted plastic that's extruded through a nozzle and built up layer by layer. We're still using that layer by layer approach, but instead we're taking these really soft polymers, such as collagen and
mm.
hyaluronic acid, modifying them in some way, injecting them through a syringe, and then depositing that layer by layer. So you're basically printing almost a jello-like material in a lot of ways.
So what's interesting about that is when a layperson likely thinks of tissue, they think of skin, they think of full organs, essentially.
Mhm.
But when people are talking about 3D printing tissue as a headline, it's a very limited type of compound that doesn't have the vascularity that one would think of normally for tissue. Is that
Exactly.
yes? That's okay. Got it. So in terms of, have you felt that there's been an acceleration in acceleration in the work that you do because of all of the new technology that's come out recently with machine learning and AI? I know, and both of those have been out for a long time, but when we're seeing these massive models, they're able to learn from themselves and then go through their own hypotheses and then make conclusions on their own and then continue to repeat their
Mhm.
experiment, repeat. Are you seeing an acceleration in the research you're doing in this field?
I would say we're more seeing an acceleration in research we're doing just due to the lowering costs and improved technology of many 3D printers. What you could buy today off Amazon, even a standard ender, is light years better than it was even, say, 10 years ago. And that's really helping, I think, with the democratization of our open source movement. So I'm big on publishing all of our designs open source. We have a paper called the Ender Shooter where you can build your own basically syringe extruder and attach it to an ender. And for those who don't know, the ender is extremely cost effective. You can probably find one for 100, $150 a lot of places. And so I think that really has helped significantly because it's brought down the hardware costs. It's allowed the slicing software to become more readily available and more easily modifiable by different groups. I think AI has a lot of potential within this field, but I think a lot of our fundamental limitations are still more based on the hardware and the biology side. So maybe
Mm.
that both the hardware itself and the cell to cell signaling, I think still provides produces a lot of our difficulties. Versus, I would say that the slicing software and similar softwares that generate these 3D geometries, it's not perfect, and AI definitely can do a lot of, I think, good to improve those technologies, but it's good enough. We have more issues with can we print something that the cells like that they proliferate in, they respond well to, but it still has some degree of structural integrity. And this is kind of known as the biofabrication window that you can create something that's really rigid, has excellent material properties and holds its shape perfectly, but then the cells hate it because the cells
Hmm.
can't really remodel the surrounding environment. They basically get trapped and they die off. They undergo apoptosis. Versus you can also have these beautiful polymers like the ones I worked with, for example, back in my graduate work. The cells love. They'll proliferate, they'll differentiate, they'll do anything you want them to. But trying to print them is extremely difficult because it's a really soft material that's extremely temperature sensitive. So we're usually trying to trade off those two, and it's hard to trade them off without just ending up with a mediocre final product. Something that's really not, doesn't have the right integrity to hold up in the human body, but also isn't really inducing cell proliferation and viability. So it's a tricky area of research for sure.
Erring on the side of anthropomorphizing this too much. I just feel like it's like trying to get a million people to do the same thing, but they all have different personalities, and you want them to hold their hands in a certain way and and, hold their arms in a certain way. But it's just extremely, extremely difficult to do something like that. That's
Yeah.
super that's super interesting. So one of the things kind of going on the using 3D printing, one of the things I loved seeing on your website was how you had students design their own rockets,
Hmm.
model rockets
Yeah.
using this. So can you kind of talk to the audience about what you guys did and how it went?
Absolutely. So I teach this class called Introduction to Engineering. As I mentioned earlier, part of the reason I was hired into this university was to help with engineering coursework. And when I showed up, this class was sold to me as a class that's open to literally everyone on the campus. And I was like, huh, that's a challenge, right? Because I'm having, not to pick on philosophy majors or studio arts majors, but majors with almost zero quantitative background, and yet they want to be exposed to the field of engineering. So I'm like, okay, how do I design a course that's accessible to all these students and yet still is rigorous enough that I feel like I'm teaching them something? We're not just building pasta bridges the whole day, right? It actually
Yeah.
is a little bit more involved than that. And so I had always kind of had passion for model rocketry. I did a lot of it back in my undergraduate college. We use these high power model rockets. We would build them almost the size of me, launch them off in the California desert. It's
Whoa.
a lot of fun. And for those of you who maybe are in the Central Texas area, there's an organization called ARG, AARG. They usually will launch out of Hutto or out east of Georgetown. And it's really fun, really, really impressive rockets in the process.
S-
Um,
So you need to like the FAA to know, hey guys, we're launching a rocket. Make sure no planes are
yep.
flying. You know what I mean? Actually,
Yeah, you do. Yeah, these can quite easily reach the 10,000 plus feet if you, yeah,
whoa. And
depending
that's
what
a
motors you're
quote
putting them in.
model rocket. I'm doing my
Model
in
rocket. Yeah.
air quotes here. Wow, that sounds like an actual. That sounds like an actual rocket.
Oh, it
In
very much is.
when when I was chatting with a buddy that I was going to talk with you, I was like, yeah, they tested. Well, they tested these rockets and then they launched them off. And he goes, wait, they 3D printed them? And I go, yeah. And he's like, that's terrifying. I go, why? He goes, because people can make actual rockets that can shoot at people. I'm like, that's fine. It's just like the model ones. So you can continue how you guys did it for your class then.
Oh, for
Yeah.
sure. Kind of regarding the safety concern, one thing that even with the most advanced of the high-powered rockets is by law, they can't have any sort of guidance system. So you can guide them,
Oh,
you can kind of guide them on the way up, but as soon as it kind of re-enters, it just has to be free falling. You can't have any. It would be great, honestly, to have some directionality so that we have easier times recovering them, right? Because otherwise, it drifts off into the trees, several miles away. But yeah, so
they
the rock.
really need to modify that law. It needs to be you can guide into safe, non-populated areas. You know,
Yeah. So I mean that's not what a hill I'm gonna die on for the sake of my own career. But so the rockets we were building are quite a bit smaller. So they're about the size, if you extend out your hand, it's probably about two of them put together. So anywhere from 6 to 12 inches rockets. So these are very small model rockets. You can go to Hobby Lobby, any Michaels, any of these stores, and you can find these kits. And so I wanted to do is with these rockets, I'm like, okay, let's target, each year it changes a bit. Well, let's target a certain altitude. Let's target how long it can remain in the air. And what we try and make these as basic as possible. So, the body is just a cardboard tube. The students will design and print both the fins and the nose cone, and then they'll model how this does in a simulation software. If you want to do it yourself, there's a software called Open Rocket, totally free. You can see exactly how a custom rocket would fly. And most importantly, you can determine stability because the last thing you want to do is launch a rocket that on its way up just spins out of control and becomes a hazard to everyone around you. And that's not to say we are
or
perfect.
shoots at you. That's
Exactly.
yeah, yeah.
So there's definitely a few students who built rockets that maybe were on the less safe side of things, but that's the reality that they're not experts in aerospace engineering. Mistakes are going to happen. I'm not going to catch everything, which
Yeah.
makes for an entertaining flight. And so after this, I've done this now for 5 years. A computer science professor came up to me and he's like, "Hey, can we apply evolutionary algorithms to your projects? In other words, can we evolve a bunch of very different looking rockets and test their relative fitness?" And eventually, the project worked out. We were able to publish a pretty interesting paper on it. I believe it's available. And if not, anyone can feel free to email me and I'm happy to provide the paper. But we produced, I thought, some really interesting designs.
Awesome. That's super cool. So this computer science professor, this evolutionary, what did you call it again? Evolutionary
Algorithm.
algorithm. So what are some I mean, that's really interesting. It's like survival of the fittest computer style. So how does that work exactly? In terms of you're putting in inputs and then it is basically crossing things off as it goes through. So how is that basically how it's working?
Yeah, kind of. So what we do is we give it kind of a constrained parameter space. So it's like as you're making these various, fins and nose cones, because those are the two things we gave it the freedom, well, and the total length of the rocket. So those three. We tell it, hey, you can freely vary these, but as you do so, you do need to make sure this is known as a stability score. So it needs to have a certain stability score to make sure it's even going to get off the ground, basically, in a safe manner.
Mm.
And then we also will tell it, well, you're optimizing or you're moving towards altitude. You're moving towards, we didn't do this, we just did altitude, but you can move, for example, towards total hang time. You can move towards maybe having a relatively slow initial velocity because it's a much nicer look instead of it just shooting off immediately and you never even see the rocket. So there's lots of different things that you can optimize for, and model rocketry organizations have a bunch of different contests that kind of go through these. But in our case, we're like, okay, you can freely vary the nose, the length, and the fins, and then basically measure, okay, well, what does that flight actually look like? And then we actually built it, launched, and like, okay, now that we know what the simulation said, how did that actually compare in real life?
That's super cool. I mean, now that because you're in space, you are in Texas, it reminds me of SpaceX that's down there.
Hmm.
And
Yeah.
it reminds me I read the Elon Musk biography not too long ago, which I absolutely loved. But it was just so fascinating how when they were developing SpaceX, they kind of let things fail in a way so that they can get proper, tests and see what are the things that went wrong. It's kind of like testing these theories in real life. I'm
Yeah.
guessing that you can't do everything in computer simulation. You have to kind of just try it out.
Yeah, and that's something I've tried, like, this idea of failing quickly is definitely something I've
Mm,
tried to incorporate because I have a tendency, uh, to be a perfectionist, to try and get things exactly right on the first go, and it leads to me just not completing projects because I just don't think I have the time to invest appropriately, and I'm like, "Okay, I'll put it off, and not eventually do it." I even have a saying. I got this from one of our pedagogical seminars, and I wish I remembered who gave it so I could give them the credit for the saying, but it was like, "I will work towards messy and imperfect action." And I have that just
mm.
written on my whiteboard to remind myself, a job that's 90% done well is much better than one that was never started at all.
Yeah,
and
absolutely.
and that was the case with this project. We there was plenty of bugs, plenty of holes. We definitely could have improved a lot of aspects of the rocket fabrication. But it's like, hey, this is a cool idea. Would we rather get it out there, maybe with its warts, or would we rather just never publish this data? So
Absolutely. Is that a lesson that you try to, put into the class for your students as well? I feel like that's such an important thing for people who are professionals, trying to make sure, hey, don't get in your head too much.
that's what I try. I offer them corrections on a lot of assignments, especially their homeworks and their exams. So, for example, if they got a 60% on an exam, I'll say, hey, redo all the problems you missed. I'll give you half credit back. So you can pull yourself back up to an 80. Because I try and tell them, like, I care that you learn the material, but I don't care too much when you learn it. Like, everyone's going to learn at different points. Some people are going to see it in the lecture and then immediately understand it and not have to study it again. I had friends like that in undergraduate who just could readily absorb material. Others, maybe more like myself, kind of had to struggle with it initially and spend a lot of time working problems to get a deeper understanding of what's actually going on. And that may mean you have a test that comes up too soon, right? That comes up before you really had a chance to fully grasp the material. And I don't want to penalize those students. I do want to reward those who have a good grasp of it now. But at the same time, I want to give an opportunity for those students to demonstrate their understanding later, to demonstrate that they have advanced and continued working on it.
You're very sympathetic or apathetic. Apathetic? No, not apathetic. Empathetic. There we go. You know what I mean?
Yeah.
Professor, which is so nice to hear, because there are not enough of you out there. How has the challenge been? How have you faced the challenge of ChatGPT being so readily available for students, and the basically influence us not to think as much? How have
Oh,
you approached
yeah.
that in class?
I know it's been a significant challenge for many of my colleagues, especially those who are in the social sciences and humanities, where writing is a larger component just of their educational structure.
Hmm.
For us, being, in the quantitative sciences, we've been a little more insulated from
Mm,
the effects of AI. Yeah, like, yes, students definitely use these various AI engines for their homework assignments. I don't put too much weight into my homework assignments. I put more weight into the exams. So if they're using AI in the homeworks, in my mind, it's like, whatever, it'll show up on the exam. If they're not,
yeah,
I have a
yeah.
pretty strict no technology policy. One thing I have been doing, so I'm teaching a first year seminar, and that's for all of our first year students. It's not meant to be a very academically rigorous class. The main purpose is to kind of get the students connected to a lot of resources at Southwestern. We'll kind of explore an interesting topic that gives them some foundational skills. So in my case, it's the ethics of science and engineering. So we've covered a lot of
Hmm.
different case studies. We're currently covering Andrew Wakefield's study on the link between MMR and autism, the
Hmm.
old vaccines and autism, which is pretty
Yeah.
interesting. But the point of that is the assignments, I give them a lot of assignments in class and it has to be handwritten. So I'm like, I'm going to tell if you have your phone out or your computer, I'm going to give you this research article. You're going to digest it. You're going to write, not an essay, but you're going to write a few sentences out. And it's a little old school with the pen and paper, but it also for me ensures that I know for a fact no AI is getting used on this. So,
That is the luxury of teaching at a small school.
oh yes, I mean I have two classes right now, one with 18 students, one with 9? I think it has 9 students. So very,
Wow.
very small classes. In comparison, say, to UT, I TA'd 5 different classes at UT Austin, not to pick on them, but that's where I did my graduate work. And these classes were frequently 40, 50, 60 students. And this was a relatively small major. Biomedical engineering was not like a hugely popular major at the institution. So
Hmm. Well, making them I mean, I think the research is actually very clear that handwriting is way, way more effective in memorization and understanding of material than typing. I think that it's pretty clear. So it's cool to see you implementing that, albeit very hard. It's hard to do that at scale, and that's
yeah.
that's the concern. Is that are we going to have an entire generation of people who are wrapped up into technology that they're not able to think on their own? Is
It's
that
definitely a
something that's
major concern.
Yeah, is that something that professors are chatting about, at your school or trying to, wrestle with?
Absolutely. I mean, it feels like every other week I'm getting an email from whether it's our dean or some outside organization saying, "Hey, learn how to deploy." Well, it's kind of almost contradictory messaging at times. It's like learn how to deploy AI into your classroom, but then also how do you limit students' use of AI? So, they do work together, and I see why, but it can definitely be mixed messaging where we see a lot more initiatives for you need to include as much of this new technology so the students know how to use it and maybe use it deliberately. And I've seen professors who've done a good job with it, honestly. So they've, for example, had the students have the AI generate an essay, and then the student's assignment is not the essay itself, it's critique the AI's work. Be like, okay, well, what is factually incorrect? What could have been done better? Did it miss any key resources? Did it maybe just make up a resource entirely? Is its argument flawed? Does it make coherent sense? So I think that's really interesting because you're treating almost the students like an editor, which in my view is a more advanced role than a writer in many ways, because you have
Mhm.
to be able to understand the writer in his or her entirety, but then also provide some sort of constructive feedback that's based off your own experience.
Absolutely. That is so very interesting. How are you basically using AI and making sure you're not using it too much? So how are you keeping yourself in check with this challenge of incorporating it or thinking less?
That's a good question. For the most part, I might be a Luddite, but I'm very limited with my use of AI. For the most part, I've used it to kind of reduce some of my administrative burden, which can grow quite high in the academic realms. So, for example, if I've already have a fleshed out CV and I need to write 300 words on what I did the past year, that's probably going to be something that goes into the AI engine and just to be
Sure.
like, here's what I've done. Can you just write this up in a long format? So that's primarily what I've used it for. Also for the generation of ideas. So I'll be teaching two courses abroad in London next fall as part of the Southwestern program, which will be a really nice opportunity. But when I was teaching one of the courses, I frankly had no idea where to start because I'm just simply not very experienced in that area. And so I'm like, hey, can you maybe make me a sample syllabus and I can see like, okay, what topics are important? What areas should I be hitting? From there, I did some pretty heavy revisions and ended up with something basically entirely different. But it really
Mm,
helped to be like, I really treat it more as a very, very powerful search engine in a lot of ways that I
mhm.
know is occasionally hallucinating some results. Because in the end, it is just recombining pretty much everything that's out there. that, that for me is interesting to see what eventually happens. I don't know if you've seen like
Mhm.
the dead internet theory
Yeah,
of
yeah,
AI.
actually explain some of these things like like what does it mean to hallucinate and then what is that theory for folks who don't know?
So with the hallucination, I mean it will just straight up make up something. And sometimes it happens because it's basically combining several different sources into a source it's treating as like a cohesive thing when it's really not. In fact, there may be contradictions internally. I'm not, I would say, well versed enough in the dead
Mm,
internet theory to know exactly how it applies to AI, but I know one of the major issues. I think the dead internet theory is basically it is all just bot interactions in the end. You don't actually have any
mm,
human input that's going into the system. But one of the things that does concern me is they've shown over and over again that AI is not very good at distinguishing itself from human content. And so, if we have these very powerful, especially the LLMs that are being trained on vast swaths of data that are maybe being primarily output by LLMs, like, is it just going to get stuck in this vicious cycle where
mhm.
it's just, different AI engines are being trained on what primarily other AI engines have generated? And how do you know ultimately? We did this
Right.
study with my students. I don't know if you saw this backlash on Reddit, the Change My View study. That team of
Mm,
Swiss researchers who went in and I guess for those who don't know, it's a subreddit that's focused on you post something saying, "Hey, this is what I believe. Can anyone convince me otherwise?" Right? And you see some really interesting, nuanced, detailed arguments. And so what they did is they actually created bots very specifically trained on these various users to offer really compelling arguments. But they did this. I can't remember the exact time period. I believe it was for months. And then they publicly revealed it and got a huge backlash
'cause they
from
they
the
didn't
Reddit.
tell they didn't tell anybody, right?
No, they didn't tell anyone. Um, but the thing becomes like if that just becomes the norm to an extent. If it
Mhm.
is, these bots that are generating these news articles, these bots that are generating, say, these opinions, at what point and then I had my students go through and see like can you tell the difference between what is a human response and what's a bot response? And these were students who knew going in that some of them were human responses, that some of them were bots. It was still a flip of the coin whether they got it right or not. And so for me, I'm like, okay, clearly, students who are already biased to know there is a bot present can't really pick up on it what hope do we or honestly the other bots have picking up the same issues in internet? Are we going to create engines that are essentially useless because they're just training almost on their own data? They're not actually getting novel insights from other humans in the process.
Absolutely. Gosh, that's so interesting. It's just going to be a bunch of robots talking to each other in a room, all saying the same thing, and no one there to be like, "You're wrong," for so that they can say, "You're right. Let me give you the right answer."
Yeah. Well, just the rate
Um,
of output, right? These bots, these engines are capable of producing so much more content than we are in a much shorter time frame. That's simply just by, probability. You're much more
mhm.
likely probably to encounter, you might be able to identify it immediately as lower grade content, but maybe these LLMs aren't as sophisticated slash don't know.
Yeah.
Yeah.
Yeah, no, it's really interesting. I mean, if someone is posting, it's like I've had, I've written little blog posts about, top whatever is happening, or how to beef up a portfolio or something like that, and had the LLMs help with that. And then I'm just thinking to myself, like, you can just spit out tons of articles saying that it's you when it's the robot the whole time. And
Mhm.
how does the internet really know? One of the things I was reading up on recently is that because ChatGPT is becoming the first line for people to search now, as opposed to going to Google. So now ChatGPT is trying to find out, well, who has the most authority online. So they are actually, I think, putting higher priority on references that have been on for longer or that are putting out content more regularly. But at the end of the day, it's still someone who's choosing what they're trying to choose. What the system is trying to choose. So how are we going to know what's
It's
what?
I mean, I wonder with that with Google, for now, they have those auto-generated AI summaries at the top of every search. And at first I was kind of resistant to them, but over time, frequently I'm Googling something for like a quick answer and it provides it and I can maybe just follow the link that it provides. But I wonder if it's almost going to undermine their own business model in a way
Mhm.
because they rely pretty heavily on you scrolling down, clicking a link, seeing more ads in the process. But if people just type in their query, get the instant AI result, and then just close out the tab, like is that a viable business model for Google?
Yeah,
are,
for
are they
sure.
aren't they gonna hemorrhage a huge advertising base in the process? Not to
Yeah.
mention running that AI result is pretty energy intensive. I can't see a way where that's possibly profitable.
Uh,
This is not my subject area domain for the audience. I'm speculating at this
yeah,
point,
yeah. Oh, no,
but
for sure. Well,
yeah.
this is why, people probably don't know, a lot of people don't know. OpenAI, who, runs ChatGPT, is at a loss. They are running at a loss constantly. They're not making any money right now. So people are predicting that they're going to start putting ads in and product placements, which they've kind of started to do in a way. But as one point or another, they're going to have to start making money. One of the big things I always mention to people is that you can use these systems to do research, to get ideas, but you have to still kind of know, you have to know the area, the subject area that the GPT is giving you the answer, because it can sound so convincing in its research and in its data that you just assume that it's correct, you know? So that's just a really important feature. And I'd imagine for those who are in school, I think of the kids who are in high school and college, to know that you still have to be have an understanding of the field.
Absolutely. Mhm.
Very cool. Well, Cody, thank you so much for joining today. This has been an awesome, awesome conversation. If you could give advice to people on how to best use AI for themselves, and to allow themselves the freedom of thinking again, what advice would you give them?
That's a good question. I mean, we were talking earlier about digital minimalism and deliberately minimizing like cell phone usage. And for me, I personally treat AI very much in the same way,
Hmm.
where I believe it's a totally essential tool. It's valuable. It's going to stick around for better or for worse in our future society. So I think as a result, it would be foolish not to learn how to use it and learn what it's capable of. But I my advice would be never to put anything through the AI. Like try and generate it on your own. See where
Hmm.
the gaps and holes in your understanding are, and then maybe use AI to help fill it in the sense. But I think if you're consistently starting off a template of AI generated content, then I think that does erode your critical thinking skills. I think it's difficult for it not to. And I think it's reversible. I think we can gain those again. But I am very, like you mentioned earlier, very, very concerned for our current elementary and high school students, where a lot of those assignments, frankly, are not designed well enough to, and they won't be. These poor teachers have 7, 8 courses to teach. They can't be thinking every single assignment, how am I going to make this AI proof? Versus, us ivory tower professors, we get 1 to 3 courses commonly. It's a little easier to make our courses less susceptible to AI over AI dependency.
Absolutely, absolutely. No, loads to think about there, and I think worth a bunch of podcasts to see how education is going to change, how learning is going to change as we move forward here. So, for folks who might want to see what you're up to and get in contact, what's the best way to do that?
For sure. I would say if you just search my name, Cody Crosby, on Google, there's a lot of us, but I will show up under Southwestern University, professor of physics. And I have my email there, crosbyc@southwestern.edu. You can definitely feel free to reach out to me over email. If you go to Google Scholar and search my name, I also will show up there and you can see a list of my publications. I try and do my best to make most of them publicly accessible. If they're not, you can email me. I'm happy to send you a copy of whatever paper it is you're interested in. So,
Awesome. Well, thanks so much, man. Super appreciate it. Have a lovely rest of the day. Okay, we'll be signing off here.
of course, thank you, Eric.